In this video series, we're going to cover header design, header components, header fabrication, and header welding. Be sure to see all of the parts in this complete video series. In this segment of the custom header video series, we're going to cover the topic of welding. An entire program could be devoted to welding. Since there's a wide variety of great sources for welding instruction available elsewhere, we're going to focus on welding techniques that are specific to header welding with a few general welding tips. On our website at stainlessheaders.com, you'll find a number of great resources for welding instruction, from publication and welding video links to available DVDs and welding tips. Check it out. Headers can be effectively MIG or TIG welded. TIG being the preferred method of welding, we're going to focus mostly on that process. Let's take a quick look at different welding equipment and accessories. While we're on the topic of welding machines, I thought I would take a moment to review a few TIG welders we have in our shop. Granted, if you're involved with a shop that is currently an active fabrication facility, this information is most likely not quite as informative as for those of you who are just getting into it. So for those of you who are looking for a welder, I hope this will be helpful. The first machine we're going to look at is a Miller Syncrowave 250. It's a real workhorse. I've been using one of these in a variety of configurations for over 20 years. They're a great value, but somewhat expensive if bought new for the average builder who may have a shop at home. They come in at about $4,500 for a new one. You can buy them on Craigslist starting at around $1,200 or $1,300 for one of the older ones without a water cooler. So look around out there. I think you'll find what you're looking for. The next machine we're going to look at is a Syncrowave 200. It's about half the price of a Syncrowave 250, and for header fabrication and welding, it works just great. They come in at a little over $2,000 for the complete setup with the TIG torch, the pedal, and the regulator all ready to go. You also might consider its predecessor, the Syncrowave 180. Once again, I think you can find them on Craigslist pretty reasonable. This is another option you might consider, an older Lincoln Square Wave TIG 175. You see them on Craigslist all the time for $700 and going up from there. They don't really have all the options you'd like to see, like pulse and post-flow adjustment, but for most header fabrication and welding applications, it'll work just fine. Something else you might consider is buying it for your project, and when you're done, selling it again. TIG welders sell pretty fast. The welder we will be using for our welding demonstration is a Lincoln V160. It operates off of 115 or 230 volts, and because it's inverter technology, it's extremely smooth. I like the portability and the performance as well. Quite often we offer used welders, so make sure you keep an eye on our website for current deals that pop up. Since there are quite a few application variables in TIG welding, the specifics can be virtually unlimited. I would like to focus on a few details that are pertinent to header welding and a few particulars that we found to work very well in our own facility. Let's take a look at a few of those right now. TIG torches. We use both liquid-cooled and gas-cooled torches. This is a gas-cooled torch. Make sure you get the flexible hose. Those rigid hoses are hard to get around the corner. Another thing I like are these large cups and gas lenses. They make it so you can extend that tungsten out farther if you need to get into a corner. Also, you get better coverage. It gives the weld a better color when it's done, less contamination. You can move a little faster. Let's take a closer look at that gas lens. These larger gas lenses help diffuse the gas more evenly, and these cups give you much better coverage. See our website for part numbers on these items. One thing to keep in mind when using these larger gas lenses is you have to increase the gas flow, at least 30 CFM or more. Now that we've been looking at some welding equipment and accessories, let's go on to purging. So you have the header tube tacked together and it's ready to be welded. Purging, does it really need to be done? By incorporating proper welding procedures, theoretically the weld is as strong as the two tubes you're joining together. And part of that is purging the tube with argon during the welding process. Quite honestly, if you didn't purge all the weld seams, you may never know the difference in the end. But for the ultimate structural integrity in the weld joint, it's advisable. Another advantage of purging is that the weld protrusion may lay flatter inside of the tube, providing better flow and considerably better performance. How do you purge something like this? It's really pretty straightforward. Okay, let's work on the purge setup. I like these caps. We size them for every header tube we make. They slip on like this. We use one of these quick couplers. They're a miniature coupler. We have a link on our website to the vendor where we get these from. It snaps on, and then we use one of these purge caps. It has a hole already in it. Slip it in, the purge setup is ready to go. When you order from us, make sure you ask about these caps. We give them to you free of charge. There's another way. Quite honestly, it works pretty good. If you're just going to do a few welds, no reason to get all set up in this. Just put the coupler into the hose, stick it in there, stuff a rag in around it, put a cap on the end, or you can just use 2-inch masking tape. You put it over the end, poke about half a dozen holes in there, crank it up to about 50 CFM for about a minute, back it down to 10, and then start welding from this end and working this way. So you're working towards where the argon comes in. Works great for a short-term thing. With the proper setup, when using argon, the gas inlet should be located lower than the exit point of the gas, and the outlet should be the same size or larger than the inlet. The point is to purge all the existing air out and to displace it with argon. A general rule of thumb is to purge at a rate and time that will produce 5 to 10 times the volume of the part being purged. After the initial purging is completed, the flow rate can be dropped back to just enough positive minimal pressure. Now that we've covered some general welding topics and welding equipment, let's look at some actual welding up close. The first thing you're going to do that involves welding is tacking. Here are a couple examples of small tack welds. As previously mentioned, the smaller the tack, the better. With proper fit up, you won't need any filler rod. For a tack like this, it takes less than 45 amps. In the next few video clips, you're going to see a few welding examples. This one shows a butt weld of 2 pieces of 16 gauge stainless tubing. The biggest battle most newcomers have with TIG welding headers is the thinner material. This particular weld was done using 45 amps and 45 thousandths filler rod. This next welding video is very similar to the last. Notice the distance of the tungsten and the filler rod to the weld puddle. The filler rod is slightly retracted each time, just enough to stop it from melting into the weld puddle, but not enough for it to lose its protection from the argon. Once again, the welder was set at 45 amps. This welding example shows welding the same material with the welder set on pulse. When the welder is set up correctly, pulse will give you the same penetration with less heat to the surrounding weld area. Not all welders have this function. It's a great feature to have, but it certainly isn't necessary. The following 2 samples are close-up views of welding with the pulse feature turned on. Once again, notice the distance of the tungsten from the weld puddle and the filler rod action. The welder settings are at 90 amps with the pulse set at 10% background and 30% peak. The welding nozzle is kept over the weld bead after the weld is completed to keep it covered with the argon until it cools. This usually takes about 15 seconds. Your timing with this type of welding is dictated by the pulse of the welder. This takes a little time to get used to. With a little practice, it becomes second nature. The pinhole at the end of this weld wouldn't be acceptable, but in this case it isn't an issue because it's picked up at the beginning of the next weld. This next weld example oftentimes concerns the first-time header builder. Welding a heavy material to a thinner material, like this header tube to the flange. Notice the technique used here. The tungsten favors the heavier flange and the filler rod favors the thin wall tubing. Along with the tungsten and filler rod positions, notice a slight movement in the tungsten. It walks up the weld puddle to meet the filler rod at the tube using the arc force to knit the flange to the tube and not burn through the thin wall tubing. As before, the filler rod is retracted just enough to stop the end from melting off, but not too far to let it get exposed to ambient air. This weld takes a little practice. Since the flanges are virtually the last thing to be welded, it can be a little daunting to build a complete set of headers and have this as the last process. With a little practice, it really isn't that hard. We have available to our customers these practice weld-up rings that are made from 3/8 thick material to simulate welding of a flange. See these at stainlessheaders.com. Now that we've covered some welding particulars, let's get back to the header we were building. 4 tubes are welded up, put back in the fixture, everything's in place. We're going to tack the flange to the tubes. Before we proceed, we're going to double check it on the chassis, make sure it still fits just the way we want it to. Then we'll dolly the corners out and we'll weld the flange on. And at that point, we'll see what the completed header looks like. Here we have it, our completed header, built in 16 gauge 304 stainless and Purge TIG welded to fit a custom application. It incorporates a heavy 3/8 thick precision cut 304 stainless flange. The header tubes at the flange ports have been formed and welded. From here there's only one thing left to complete, and that's securing the collector. There are a few options for doing this. Some builders like to fusion weld the slip joints right to the header's primary tubes for a permanent attachment, while others like to use collector retaining tabs like these. Since the slip joints are a close tolerance fit, leakage is quite minimal, and the collectors can be removed at a later time for modification if necessary. Well, I hope you found this video series helpful. At Stainless Headers Manufacturing, we're here to help you meet your header needs by either building your headers for you or supporting you on your own project. We have all the components necessary for you to build your own headers, from mandrel bends and header flanges to collectors and header tubing. If you're looking for a large selection of header components or header building advice, make sure you see us at stainlessheaders.com or call us at 1-800-290-3920. Make sure you see us at stainlessheaders.com for all of your header component needs. We carry a complete line of header flanges, mandrel bends, merge collectors, and stainless header tubing.